Hey everybody. I get a lot of questions about my Powerwall anytime I post anything, so I thought I would take a minute and do a quick video walkthrough. So all my stuff is housed in this shed that I bought at Costco, and this is completely detached from the house. It's a bit close, but it's better than being inside the house. Anyway, so let's dive in. So here you can see pretty much the entire setup. We have the main device wall here, monitor for the computer that's there. We'll go in that in a moment. And then we got the main battery here. So this battery is made of 1050 SPIM08 lithium polymer battery pouches, essentially. This is a design that I came up with to basically, to do the least amount of work possible and make them maintainable. So I can do a separate video on the actual design of the packs, but I'm just going to continue with the overview. So yes, we have 1050 of these in here, and it's basically set up as a 25P 14S3P system. Now I know that sounds like BS to most people, but that's what it actually is. So there's 42 packs. Each one contains 25 of those cells. It's split into sets of 14. So there's 14 in series, and then there's 3 of those series in parallel. So as you can see, we're using Baytrium Longmons here. I'm using the Baytrium BMS system for this. We're not going to get great, temperature readings from the device itself of the actual cell, but it'll give me an idea, and obviously it'll do the balancing and other monitoring that we need for this system. So you can see here that in the series connections here, this is all 2-gauge wire. I forget exactly what the square, area of that is, but that's what's basically linking them. So you can see they're here, and then there's some in the back as well to create the series. Otherwise, if we come back out here to the connections, we have this 2-aught gauge wire, which is, I do know this one, 67.4 millimeter cross section, squared that is. And then we have the main data line coming from the batteries. And this is all extended with, solid core Cat5. And solid core isn't the best, but it'll work for what it needs to do. It doesn't move very much. I'm not worried about it breaking. We have 2 kind of garbage fuse blocks themselves, but the fuses themselves are actually high quality fuses that will do the job and way better than the Chinese ones that come with these actual fuse blocks. So then if we keep going, we have our main lines here. Put a lot of slack in here, so this whole battery pack is on wheels, so I can move it out and do maintenance on it if I need to. So that's what the slack is all about. If we continue on, obviously we have the shunt for the Baytrium. Coming down here, we have the shunt trip breaker, which is controlled by Baytrium as well, and this will disconnect all loads and the chargers and all that stuff in case of a critical event. And this is 24 volt driven. We'll go into how that's done a little bit more in a bit. This is a distro block that I made, so there's 2 posts inside here and a piece of plastic in the middle, so that's nice and safe, and it can't arc, and nothing can touch it, including myself. We have a couple breakers here. We'll go into what those are in a moment. And then we have basically my giant inverter. So this is an 8K or kilowatt inverter. It is UL listed. Actually, everything in this shed is UL listed outside of the battery itself. So yeah, this is what powers the house. This is a 240 volt split phase, as required by kind of North American standard for the most part. Obviously the main are battery lines. And then this is the AC lines that are directly connected to the device. And this goes out to the house via an underground line. Now kind of backing up to the whole device wall here, we have a couple different sections of the wall, and it's not really sectioned out, but there's power requirements that need to be stepped down and over and around. So the whole shed is powered by the battery itself, so there is no conversion. All the AC or all these devices that have AC power brick and stuff like that, they've all been removed, and I've used step-down converters for those. So I'll show you those in a little bit. So since the system is a 48 volt nominal system, it was pretty easy to find step-down stuff for that. So looking at the wall here, kind of starting from the bottom, we have the main breakers for the solar, which goes into this Schneider Connext MPPT 8600 charge controller. So this charge controller is for one array of my house. I have 2 separate arrays. So there's one here, and then there's another one here for the other array. And you can kind of see, there's the breaker again for that system, and then there's the Smurf tube which comes across here, which actually carries the lines from the solar. And then you have the actual battery lines themselves and the data line for the Schneider, or the COM box, which we'll go in a second. So coming back to the wall, kind of start in the middle here. So what we got here is a 48 volt block, and this comes directly off the battery. Then we have a step down from 48 to 24 volts, which then powers this block. And this block is for all the 24 volt control systems. So there's several different things that rely on 24 volts, like my contactors and the ATS, and actually the shunt trip breaker for the whole system. We have a couple other step downs. We have this step down, which is a 5 volt step down, which is used for the computer, which we'll go into in a moment. And we have a 12 volt step down. This is a 10 amp 12 volt going for the exhaust fan for the shed. Speaking of which, we have a 12 volt thermostat here. There's a temperature sensor closer to the roof of the shed. And then we have a fan controller, so it's not just going crazy forever, because it's an 80 watt fan, so we don't need it blowing that hard. Coming back to the power blocks here, the 48 volt block will power the computer through this step down. The Baytrim itself just gets straight 48 volts. The Wi-Fi access point, the LCD, again this step down, and then the fan system down here. On the 24 volt block, we have the COM box, which basically powers the COM box itself. We have the shunt trip for the entire system. We have the inverter switch, and then we have the ATS. So this is all nicely labeled and whatnot, so I don't forget. And you know, the electrical people think, oh yeah, this is what this is. So, stepping to more of the control systems, we have, let's go back over here. So this is the Schneider COM box, and this talks to it over what they call ZAN bus, which is kind of like an encapsulated CAN bus to make it their proprietary version. And it's daisy chainable just like CAN bus is. So basically this output goes to this box, and then this box daisy chains out to the box behind me across the shed. You can see that there is a Modbus connector here, this RS485 specifically, and that goes to my main control. So basically this is a DF robot, Latte Panda, which is a Windows PC, which also has a Arduino compatible microcontroller, specifically the 32U4. Now, the reason why I chose this one is because I wanted something all-inclusive for these two things, as well as being somewhat low power. One of the main functions that it does, outside of running the Watchman software for Baytrim, is the two adapters I have on here. One, I have CAN bus, then over here I have Modbus. So like I said, the COM box speaks Modbus, and the Baytrim speaks CAN bus. So I wrote a piece of software so that the Baytrim can control the two solar chargers via the COM box, in terms of charging voltage and charging amperage based on whatever state that the Baytrim happens to be in. So this is actually available on my GitHub. I don't know if we made it completely public yet, and I'm not sure if I will. We'll see. I'd like to share it, but I don't want to piss people off. So moving along here, in terms of controls, this is a Ames Power kind of remote panel for the inverter that I showed you earlier. And I've kind of hacked this switch here. As you can see, a wire coming out the top of here, but basically I hacked this switch into a relay up here. And so the Baytrim can actually turn the inverter on and off. And so when it is, the battery has depleted, it'll turn the inverter off and use the automatic transfer switch to switch to grid, and vice versa. We have some other ancillary equipment like this SPDT relay. Actually, this is an SPST relay, but it's solid state that I designed myself. There's also another one of these in ATS. I'll go over that in a minute, but this also has a delay on it too. So it'll turn the inverter on immediately, and then it'll also turn the inverter off about 5 seconds after it's switched to grid to make sure there's a good solid transfer. Moving along, here's the main monitor for the whole system. Not going to turn it on right now, but it is running Watchman. There is the Baytrim itself. You can see it's connected to the Latte Panda via USB. That is the relay that controls the shunt trip. Considering that the relays on here are only 10 amps, I had to use a separate, I think that's a 40 amp or something along the lines of that, relay to control the shunt trip, so I didn't smoke one of the relays on the Baytrim, since I believe it's a 20 amp, I think a 20 amp shunt trip, I don't know. It's momentary, but I didn't want to chance it. So again, you have my Wi-Fi access point, which gets this network to the house without having to run wire. You'll see there's a little step down converter on there from 48 volts down to, I believe, 9 volts for that device. And then also on the back of the monitor, you'll see that there's one there too. So basically, this is how I was able to get everything to run without having to run AC power connectors for these different devices. Oh yeah, one other thing I don't know if I showed you. If I did, whatever. This is the breaker for the charger behind me. Wow, this big brain fart. And this is for this charger right here. So yeah, that's kind of the system. I think what I'll do now is I'll cut over the ATS and we'll take a look at that. All right, so here we are over at the automatic transfer switch on the inside wall of my garage. You can see here we have two rather large contactors. These are 100 amp contactors, 3 poles. This is a big breaker, but it's also a shunt trip. So it has a shunt trip that's controlled by the state of these contactors. So it's kind of like the last defense. So if these contactors, for whatever reason, the mechanical interlock fails, then if these ever get in the same state, it'll actually trip this breaker. So it protects basically the inverter and the grid from itself. Again, I mentioned earlier that there were a 24-volt control lines coming from the shed, and that's what this is coming into here. So this here is an SPDT relay, solid state of my design. I couldn't find one that was cheap and or available at all, so I just designed my own using MOSFETs, and they control the state of these two contactors. It is very fast. It has a 10 millisecond switch time, and it would be faster, but I had to account for the state of the transition of the contactors, because these specific contactors you can't load one and have the other one switch. So you can't, and have it switch faster. Like as soon as you load one, it locks the whole system up. And so it had to be able to, it's basically a break before make system. So there's a bit of a gap. I haven't actually measured it, but there's a bit of a gap switching between the two sources. But you know, we deal with that by putting small UPSs on mission critical, or you know, basically like network equipment and stuff like that in the house. This breaker is being fed by the meter. This goes into this breaker, and then the breaker goes to the main load panel. This side here is coming from the inverter. As you can see, a slightly smaller gauge wire there. You know, we only have 60 amps per, or maximum, which won't even hit, but basically 60 amps per phase coming from that inverter. So yeah, that's kind of the main system. Let me know if you have any questions, and I'll try to answer them in the comments. Thanks.